If anyone wants to follow along, you can download, there's going to be 2 sets of slides from GitHub, JuliaCon 2015. One thing to keep in mind, though, is there is a data folder that has approximately 250 megabytes worth of data in it. You can either download it live over the Wi-Fi or from Amazon, or you can clone it from GitHub. But in either case, if you aren't that interested in following along and just want the slides, you may just want to take the notebooks. Well, you won't be able to do the examples without the data, but if you don't want to download 250 megabytes and then unzip them and do that, then just take the notebooks.
You know how to do that from Julia Box? I know how, if I put like the vertical, everything, right? Sorry. Please continue.
I don't know how to do it from Julia Box. I'm sorry.
So you mean sync to Julia Box?
Yes.
I think it's pretty easy.
So I can just put it to an RTE.
Yeah, I don't know if Julia Box is like you. Come on, I don't know, maybe. Try one way to find out.
Yeah. I'm just excited you're doing bike-share data. I've been studying DC bike-share data.
Well, I'm just excited that there's a non-zero number of people here. So when I when I saw that Arch was going to be the other talk, and he's doing high performance, I actually want to go to that talk myself. And so it's been kind of a, like I said, I'm glad there's a non-zero number of people here. So I guess we'll get started. So my name's Randy Zwitch. I work at Comcast. Just as a disclaimer, nothing I talk about here has anything to do with Comcast. That's probably a good thing. There's going to be 2 talks, so this is a 90-minute time slot, but there's only so much you can talk about relative to bike share data. So I actually have 2 presentations prepared. One is going to be the one that's on the screen now, and there's going to be a second one that talks about the Vega visualization library that I've been working on. So we'll go through this example, I don't know, maybe take a 5 or 10 minute break, and then we'll go through the second set of examples. Okay, so if you were at the regular conference, obviously it's a very enthusiast crowd, so everyone is extremely advanced. I was presuming that there would be at least some beginners here from Julia. I guess the good thing about this being taped is for the next 1,000 users or 10,000 users, there will be at least one talk that somebody can look at and say, this actually resembles something I might actually do, as opposed to maybe astrophysics or genome sequencing, which that's really not my background. So what I wanted to do was just show using the City Bike API for New York City, how to work with APIs, how to do some common summarizations using the data frames package. I also wanted to show some just common visualizations to answer business type questions. So this will be a very lightweight, I think easy to understand talk. And if you have any questions, please let me know. Just let's have as interactive as possible. Okay, so if you're not familiar, Citibank piloted a program in New York City. I believe they also do it here in Boston. Philadelphia has a different type of company, but it's a bike sharing program where you can either buy a subscription to use bikes, you take them from one station and then you return them to another one, or I think you can pay on a per ride fee. And what's really great about the City Bike New York City program is that they provide historic data as well as a real-time API that requires no authentication. So they really want to encourage people to analyze their data and to show what the success of the program is, as well as allowing application developers to extend their functionality. So here's just a quick picture of the website. So their visualization isn't so helpful because the bike arrow icons are so big that it basically shows you where Manhattan is. Otherwise, it really doesn't give you that much. It is creeping somewhat into Brooklyn. But this is the page that they show you when you go to the City Bike site. Okay. So what example I want to do is cover all of 2014. And they provide archived data sets for every month where they tell you down to the ride level characteristics of the customer that rented the bike, where they got the bike from, latitude and longitude, the duration of their bike trip, and several other attributes. So what we're going to do is we're going to go through and analyze the entire 2014 data set. So this is the data directory that I was talking about from GitHub. So I already have this downloaded on my computer. If you clone this from GitHub, I suspect it will be slower than if you clone it directly from City Bike's Amazon S3 bucket. But at the same time, if everyone connects to the S3 bucket from here, I don't know if that will kick everyone off. So, we'll see how it goes. Okay, so the first thing I do is just, I'm setting my working directory to, okay. And so if you run this bottom set of commands, it's really just a simple loop. And, so you can see that it's really somewhat trivial to download a lot of data, and in this case, 12 CSV file or 12 zip files that get extended for CSV. And then finally, at the bottom, I just do a quick shell command that unzips all of the files so that we don't have to really deal with that inside of Julia. It's just at the operating system level. So when you do this, you will see something like the following. MIT has surprisingly good Wi-Fi. So it won't take very long. Okay, so at the bottom, you can sort of see 12 archives were successfully processed. That's the output of the final command that unzips all of the files. So now in a directory that will be similar to the working directory I'm using, you'll have 24 files now. You have the zip files, you also have the CSV files. And from there, we can go ahead and create a data frame with all this data. Hopefully everyone's familiar with how to load libraries. Again, like I said, I realize that everyone here is pretty much an enthusiast of Julia, so this is perhaps not the talk for everyone. But and then the next thing we can do is, rather than try and write all these things out by hand, we can just select the CSV files. And the one thing that's interesting about this is how real-worldy it is. So with a lot of the other talks, talking about Large Hadron Collider and all these other things, there is, I would assume, some level of control. But what you can see here from the file descriptions is the file names change naming format, and it is the case that they also change file format. So we'll talk about how to deal with that. Okay. Now, this is an extremely wasteful operation, but this is one way that you could build a data frame from all 12 of the files. If you run this, it's going to take approximately 5 minutes or so. It's a very naive way to create a single data frame, and it's very wasteful from a memory perspective, as every time you loop through this, the data frame gets copied. So on the first time through, it's not a big deal. The first file gets read in, a data frame gets copied. But because we keep renaming on top of DF, DF stays in memory while the next one is loading. And then because you're using VCAT or vertical concatenation, it does that concatenation. You have two copies at one point. And then once the file's been read, then the next one goes. So each time, I would think it's actually, well, okay, so there's an append function by the person who wrote the majority of the data frames library. But this is certainly a naive way to do it. I've already done this, so we're not going to waste that much time. The point of this is, though, is if you wanted to learn on a real-world data set, it's not hard to acquire real-world data to play around with. In this case, there was just over 8 million rides that City Bike provides data for the 2014 period. And then they give you 15 attributes. So we can just find that using the size function. Okay. So now if we want to go on and actually explore this data set, we're all set. We have one big table. Again, it has 15 columns in it. So if we want to just figure out what's in there, certainly we can use names. So again, like I said before, trip duration, the station where they started, latitude, longitude, and then the last three are actually the interesting ones. So user type, birth year, and gender. So they do provide some demographic statistics, or demographic attributes, excuse me, so that we can calculate statistics and understand how people are using the bike share program in New York City. We can understand by age, by gender, and then by the type of license that you have, whether you have a subscription or you're a one-time rider. Now, because there's 15 columns, it really doesn't fit well on the slide. So I was just going to, here using the head function, we can see just partially what our data looks like. We have the trip duration, which is in seconds. We have the start time and end time, the station ID, and again, there's 11 other attributes that go along with this data set. One thing that we could do is go through and actually do describe. Actually, I am going to do this to make the point. So there's a lot of areas for improvement in terms of performance, and this is one of them. The describe function is quite a bit slower than if you're familiar with R and have used their functionality to describe data sets. And the reason I point this out is not to point at John, but actually to point at myself. So I modified this function because I wanted to get descriptive statistics for strings. So I put a horribly inefficient way of doing this into this function and pretty much made it useless. I always meant to go back and fix that, and I guess there's still time. But what you get is, for numeric attributes, you'll get your basic summary statistics, and then for strings, it will go through and tell you how many strings actually have a value relative to being blank and the percentage value, and then the number of unique levels, so you can understand whether or not the value that you have is a key column, or if it's a factor type of column where it has maybe a dozen levels. So no, this is actually still running. What's nice is it prints out the output at least during the period, so you can get excited for when a new summary statistic shows up. We should be done pretty soon. And then, of course, Julia doesn't know anything about the data, just like any other programming language wouldn't. So you do occasionally get things that are weird summaries, like birth year. Knowing what the average birth year really isn't kind of useful, but it is certainly printed out. And you can also do this by column, which is a lot more efficient. So if we just indexed into the data frame for trip duration, you can see that it's nearly instantaneous. Again, kind of proving my point about how I broke the function with the string processing. Okay, so we have our data, we've kind of looked at it. Now there's any number of ways to actually visualize this data. And what's funny is that I wrote at least this part of the slides before I got to JuliaCon. And there's like at least 3 or 4 more libraries that have been presented in the last couple of days. So this isn't even an exhaustive set. If you wanted to go through, there are a lot of great visualization libraries. I think Gadfly is sort of the incumbent at this point. Vega, I think, is a very great library, and I'll tell you why later. Then, of course, Plotly is great. Bokeh is great by the Continuum Python guys. So again, there's a lot of great ways to look at our data. I'm going to use Gadfly for this. Okay. So in terms of the business questions that we can visualize, I just picked out 3 here. So how does overall ridership change month to month? So the one thing that's obvious about riding the bike is there's a really good period of time, and then there's some really bad periods of time. So for someone like myself, I would never ride my bike in December, right? It's just going to be too cold on the East Coast. I know there are some very hardcore people that ride, year-round. And then the same thing, in the middle of July, I probably am not going to be riding a bike to wherever I'm going because I would be so sweaty that I probably would not think that a bike was, appropriate transportation. But regardless, we can look at that and plot this and understand how the people of New York City are using bikes by month. Secondly, does the duration of the ride vary per month? So the same reason. So if you have this temperature effect, if people are riding in December, do they ride really short rides relative to perhaps April when it's a really nice day out and they take the bike out all day? So again, we can evaluate that. And then finally, do men and women participate differently in the rideshare program, and does age matter? So we can answer all 3 of these questions, or 4 of these questions, very easily using visualizations. Okay. So if we want to use the Gadfly library, again, we just load it up. And as I said before, what's interesting about this example is how real-worldy it is. So with my work in industry, you often get just files that you wonder why somebody would do something like that. Why would the file format just change in the middle, changing the date format, changing the number of columns, all of a sudden going from commas to tab delimited and so forth. In this case, what Citi or their vendor did was switch the date format. So there's a simple function here to actually fix that. So what we have is a date part function that I wrote that just takes in a string, and it looks to see if there's it does a regular expression to see, or excuse me, not a regular expression, just a simple match to understand whether or not they're using hyphens between their dates or if they're using slashes between their dates. And once we do that, we can just do a simple list comprehension to add a new column called month to actually parse out what month this is in. Since we're doing all 2014, I didn't feel that it was necessary to actually fix the date stamps, right? We just know that the data set goes from January 2014 to December 2014, and thus month is sufficient. And then finally, I just did a quick, added a quick random number to the data set. Because when we get to Gadfly, you don't really want to plot 8 million points. Humans can't really deal with that much information. Computers can't really render that in a decent way. So we'll use just the random number to make our data set smaller and easier to visualize. So if we wanted to just start off with the question of how to ride, I guess I have to run this.
Are we
Oh, it's definitely still loading Gadfly. I actually preloaded all of the libraries before the talk to try and compress this down a little bit. But again, even though we're going through this, there are 8 million records. So we are doing a bit of data transformation here. It's not a non-trivial amount of data. We have 8 million records. It's probably something like 5 gigabytes of data once it's in a data frame in RAM. So it will take, I don't know, 30 seconds maybe.
Did you check that it also has the same number of columns before concatenation?
So the file formats are actually, they're exactly the same. They just change within the date form column, the date stamp, they change the format of the date. So that's the worst type of error in my opinion. When you can't stack files over, on top of each other, it's pretty obvious that you're going to need to do something. When the files all still have the same format, but the data type or the data formats change inside the columns, that's the worst type of error. So like even data sets like this, we're using 8 million records. At work, I frequently use billions or even trillions of rows, and you don't really look. You're not going to hand observe 1 million or 1 billion or 1 trillion records. So you just fight with lots of errors. So yeah, Gadfly. Just to be clear, I didn't break the string processing in general in Julia, just in the describe function. So the date parse function is as fast as it's going to be, I suppose.
While we're waiting, can I ask you a question about data frames?
Absolutely.
I was talking yesterday with Jacob Quinn, who told me he hates data frames, swears off data frames, and he thinks that nullable arrays are going to replace data frames. Is that a common opinion?
I'm going to punt to Jacob, who's right here. We actually had quite an interesting discussion at dinner time about this. So since it's his comment, I'll let him comment about his own opinion.
No, so my data frame is okay, right? and it's good. It's okay for certain tasks, but and I've talked with John about this too. You can very quickly get into situations where you just can't get the performance that is really possible in Julia because of internal design and overall design decisions of data frames. And the other aspect is I come from a very strong SQL, write my query, get my data, and that's a lot about how I think about transforming data. And so when I use a data frame, a lot of the operations I want to do are those. And it's a lot of syntax overhead personally for me to try and do what I want to do, and then sometimes you can't. And it's because we're trying to coerce all of these different operations onto data frame. And it's certainly possible, but that's a lot of work to define all of the semantics and functionality to work on a data frame without just actually being like an SQL table that supports full SQL.
So this is actually a good segue now that the data has finished loading. This is one of those operations. So if you're familiar with SQL, this would just be a group by. But what you end up doing here is using the by function. Pass the data frame. The month refers to the column month, and it's listed as a symbol. And then we have an anonymous function that is sort of cheating here, or at least not the way that you would think about it. So here's that cognitive overhead. So if you use the size function, it will tell you how many rows that you have in a data set. And the by function here breaks up a data frame by the column that you're using. So I'm applying the size function to each of the by groups, and in this way, you're getting a count of the number of rows per month, and where each row represents a ride that somebody took on a bicycle. So when you're talking about people who are familiar with SQL versus not, this is very awkward. You know, it doesn't really make sense why this works if you think in a really heavy SQL syntax, but it does work. So when we run this, it doesn't take too long. I believe it's part of the data frames package. This is kind of what Jacob was referring to. There's operations that can only go along with you know, certain types of data objects, and for a common array, it wouldn't make sense, right? So I don't want to get into the difference between arrays and matrices. That would, or excuse me, matrices and data frames, because that would sort of derail this whole thing. But it only really makes sense to do by group processing in a data frame where the columns are explicitly put together. Okay, so then you can see here in terms of the number of rides, it's very clear that there's a monthly difference here. In the early months of 2014, whether this program is ramping up or whether it's just plain cold outside in New York City, there's about a third as many rides as there are in the summertime. And then when you get towards November, December, again, the rides trail off. But an easier way to see this is actually to plot our data. And so here I'm using Gadfly. The syntax probably looks familiar to everyone. When I get to the second part of my talk about Vega, I'm going to talk about Gadfly and what I'm trying to improve upon how we plot things. I did not pre-warm up for this one, so Gadfly is going to take a little bit of time here. The rest of them shouldn't be so bad.
By curiosity, the date parse function that took time before, does anyone delay? Is it just because it's too much data, or there's some obvious optimization to be done?
To repeat the question, it was, could the date parsing function be optimized? Possibly. You know, it really depends. I mean, because of the way what I was trying to do with just searching for whether or not there was a slash versus a hyphen to determine the date type, there's probably a better way to do it. However, going across all those strings, there's no type instability in that function as far as I know, because you're staying in an ASCII string, you're looking for a string, and you return an ASCII string. So it's not, as far as I know, there shouldn't be any massive improvements that can be done. So when you plot this function, now it's a lot more obvious that the rideshare program is dramatically more popular during the warm months relative to the cold months. And again, that's perhaps common sense, but it is proven out here and easy to see with our bar chart. It's quantifiable, yes. Okay. So does the duration of rides vary per month? So that's another column that we have in our data. We can go through and again use Gadfly. And this is what I was talking about. So we're going to do a box plot here. So if you're familiar with how box plots are calculated, you need to calculate 5 summary statistics. We're doing this for 12 months, and then we have 8 million observations. So the question really becomes is, do we get anything from calculating our mean and median, 25th and 75th percentiles and outliers from using 8 million records relative to, say, 1% of that? And at least for this demonstration, I'm asserting that no, you don't get any benefit from using all 8 million. So when we run this, we're going to calculate box plot on 1% of the data. Okay, and so what we can see is that, yes, the duration of the rides do vary per month. And we can see that by the length of the boxes for each of the columns here. And then, of course, the horizontal lines at the end, the whiskers, if you will, they also show that, you know, at the extremes, the rides are much longer. And again, that it proves the hypothesis I was talking about before, where when it's nice out, people ride bikes longer, and when it's perhaps not so nice out, they ride shorter distances. And then the other thing that you notice about this is interesting, or at least to me, is by definition, the bottom bound is 0. You don't often see this in a lot of data that you're looking at, like when you're doing some sort of experiment. It's usually some non-zero. But in this case, the whiskers here are all, you know, at 0, because to have a rented bike ride, you have to have a non-zero amount of time. Okay. The dots represent potential outliers. So if I'm not exactly sure which Gadfly uses in terms of the endpoints of the whiskers, if it's 95 or 99%, but all of those dots represent points that are potential outliers in the month, that are, you know, where the ride was so long that you may want to actually investigate. So. It's in seconds. So it actually does make sense when you look at it. 3,600 seconds is an hour. So you can see that most bike rides are about 20 minutes. So that makes sense. People are perhaps using it as an alternative to the subway, or, you know, in the case where they're going from one part of the borough to another, that's just, you know, 30 blocks or something, they just ride a bike.
If anybody doesn't know, it might also be worth saying that rides less than 30 minutes don't cost extra, but rides longer than 30 typically do. And you can exchange a bike and get another one within the 30-minute window and not pay extra. So there's a pressure below the 30-minute mark.
I did not know that. Thank you for contributing that. That is very interesting. That's where domain knowledge certainly comes in when you're doing analytics, because I wouldn't have known that otherwise, that people are gaming the system. Potentially, I don't want to besmirch anybody that's running.
It's designed that way. It's a good thing.
Oh, okay. Well, so there you go. And then finally, do men and women participate differently, and does age matter? So what we can do here is, again, we can use by-group processing, and again, it's awkward, right? It doesn't feel like SQL does, or even Link, you know, that people brought up yesterday. But again, we can go ahead and use the by function on our data frame. In this case, we'll do it by gender and birth year. Hopefully it won't take too long, because again, trip duration is an integer, so we should be able to do this pretty fast. Okay. So now you can see that we have gender, birth year, and then average trip duration. You know, as I talked about before, plotting 8 million points really isn't going to be an easy way once we get to a scatter plot. So I took the average here just to summarize the data down and make it a little easier for us to plot. And because I don't like sort of 0 and 1 for gender, I just have a really simple function here to reclassify those values into character strings. And then the same thing with calculating age versus birth year. It's a little hard to kind of do in your head, like, do people in 1979 use bikes differently than people that were born in 1984? So if you just take 2015 minus the birth year that's reported, then we can go ahead and get their age approximately. I saw everyone else's presentation. I was like, that's really a shame when people have yellow text, and of course now I've done it here. So actually, let's change that real quick. It will take just but a second to re-render. Okay. So what we can see here now is that with our scatter plot, we can see that there is a difference between gender, at least. Okay. So male is the navy blue, and female are the green riders. Now, like all descriptive statistics or descriptive plots, this doesn't tell us why, it just tells us it is, right? So is it because women ride further? Is it because that men ride faster? Do women use bikes differently than men? In some ways they are. We just don't know how, but we've shown that there is a difference across the age groups on how men and women use the bikes. Now you can see that there's a lot of noise towards the 70 and above age ranges. Again, that's probably not surprising. If I thought about my grandparents riding bicycles, I'm not really sure how that would work out. But if you look at the plot in general, it's approximately a horizontal line, which indicates that age really doesn't matter in sort of the prime years. And then once you get out further, we do a lot more noise in the data. Okay. So that's just 2014. So as I said, City Bike really wants people to analyze their data. They provide these files as CSVs, but they actually have a real-time API. And what we're going to do now is actually access the real-time API and plot where the most bikes are available in real time. Okay. And the way that we're going to do this is using the requests library. So this has been what I've used anytime I've been accessing web APIs. There's a handful of others. So there's a handful of ways to do this. And then it returns JSON objects. So we use the JSON library to parse the data. So as I talked about before, because they really want to be so open with the data, there's no authentication for their API. You just make a GET request, it returns JSON back to you. As opposed to something like I also wrote the Twitter package if anybody's used it. That's a huge OAuth nightmare of signing tokens and doing all sorts of things. And that's not an easy way to get people to use your data. And I suspect that Twitter does that on purpose. But in this case, it will take us literally just a few seconds to get the real-time data of bikes in New York City right now. It takes longer to load the libraries than it does to actually get the data. Okay, and as part of the request library, it will tell you, it returns a response object And in this case, the response code of 200 means we had a successful request. So we did receive some message from the API. And when we use the JSON package to parse the data, we can see that their JSON can be represented in Julia using the dictionary type with 2 entries. There's the execution time, which isn't really that helpful. And then there's the station list that has all of the data in it. So if we want to find out how many stations there are, we can go through and just, again, use the size function. So there's 329.
The dict, it was created out of the JSON that was done.
Yeah, so if you...
Is it like from a JavaScript object?
Yeah, so if I go control... Wouldn't have thought it would take this long. It's only a few kilobytes of data. So this is what was returned. I'm not quite sure what was taking so long in terms of Julia. But so you see they return back information about all of their stations in a JSON object. And then we translate that using the JSON library. Okay, so there's 329 stations in the city bike program. And if we want to find out what data they return back, it's slightly different than the archive data that they return to you. So because this is real time, they don't give you the demographic information. They just give you the location of the bikes, the available bikes that they have, the total number of bikes in the station, and so forth. And we can calculate the top 10 stations having bikes just using some pretty simple arithmetic. So in this case, all I'm doing is creating empty arrays and then taking the keys out of the dictionary. So when we do this, okay, we can see, these are the top 10 stations where the city bike program currently has bikes, up to whatever that was 10 seconds ago. East 17th and Broadway has 48 bikes, 81% of their bikes remaining. You can see Central Park at number 9 only has 69% of their available bikes, so are in Lafayette Street in 8th. So perhaps you'd say that those are more popular locations. Certainly I would believe riding a bike through Central Park would be a fun activity. So the other thing that we could do is actually do a real-time map. So when I originally started off this talk, I showed that the map that City Bike shows you, because the arrows are so big, all it does is show you where Manhattan and part of Brooklyn is. But what we can actually do is create a plot in Julia to actually show you where those stations are. So this is going to use Vega, which this will be my transition into talking about Vega. One thing that's great about Vega is that it allows you to make maps, choropleths, and such. So what I have is a shape file that I modified. It was originally New York City with the 5 boroughs, but the program only goes on in Manhattan and part of Brooklyn. So I took those out of the map because clearly there's not going to be any bike stations there. So this is some really ugly syntax. This is what you need to do at the really low end to build a visualization in Vega. However, when I talk about it in a few minutes, you'll see that I've created a much higher level interface. So when we plot this, well, actually this is just the function itself. Okay. Okay, so these are the top 10 stations in New York City right now having the most bikes for the city bike program. And I put real time in quotes before because I haven't added any animations or anything to this, but their API is so responsive that it would be trivial to set up a loop or some other functionality to just ping the API every 5 seconds and just keep redrawing the map. It took a long time to draw the map this time, again, because it's going through the compilation cycle, but to redraw it again, right, is trivial. So we could actually make a real-time dashboard with Escher, and you'd actually be able to see, where and how people are using bikes. So that's it in terms of the first part of my talk. Hopefully, like I said, this was useful for some of you. Again, everyone here is a Julia enthusiast, or at least most people, so this may have been the lightest talk of the conference, but for the next 1,000 or 10,000 users, hopefully they appreciate a normal example. So why don't we take a break? It's 1:53 now. We'll just start at 2 o'clock, if that's fine with everyone. So the second part of my talk, I wanted to go over the latest project that I've been working on because it sort of directly relates to the topic of the day, everyday analytics and visualization. So my subtitle here is Collaborators Wanted. So I resurrected this package from the dead. It would be great if there were other people who wanted to work on it. So here's just some of the highlights of why we might want to do this. So do we really need another plotting library? And this is sort of the open source tradition of duplicating effort everywhere. You know, at one time there was like 6 testing packages for Julia. You know, people just kept doing the same thing over and over and over again. Visualization, I might argue, is a little different. Yeah, there's always room. There's a lot of ways to build visualizations. And in this case, what I'm hoping to achieve is a really, really simple interface for plotting. So when we talked about Gadfly before, or if you've used Gadfly in the past, it's based on the grammar of graphics, which academically is a very great way to think about visualization, that each visualization is just a series of components that you put together in order to convey the relationship you're looking to convey. However, I feel that I can't use Gadfly without always reading the documentation or copying something I've always done, because I can't remember if the fill attribute goes into the theme or is a part of the aesthetic, or where do I put this, and so forth. And so for me, this is, you know, I want to be clear that this is not me criticizing Daniel in any way, or Hadley Wickham for, you know, ggplot. You know, it's a perfectly valid way to think about visualization. I just don't like it. Okay, so what I've tried to achieve is to have the most minimalistic interface as possible for creating graphics. So where I've defined new functionality, actually it's good to point out, so John actually started this package. Where I'm referring to I, it's still somewhat we, because I'm using the code that he started with. If you looked at it today, it may not be familiar, but so what I set out to do was make an extremely simple interface. So what we can see here is for bar plot, creating a bar plot, we have these 3 arrays. You have X, Y, and then the grouping. And in this case, there are literally only 4 arguments to this function that you can do. And they all make sense, right? It's like, what data do I want on my x-axis? What data do I want on my y-axis? It's optional to pass the grouping in. If you didn't do that, you wouldn't have to additionally pass the stacked parameter. So stacked is false by default. So you would just get a normal bar plot if you had 2 series. But for me, cognitively, it's very easy to just remember these 4 components. I don't need to look up the documentation. I don't need to do anything. And it's a fairly aesthetically pleasing plot. The default color scheme is not so good. It is a little better than ggplot too, in my opinion, but it still could have some improvement. So, okay, so why not do it in Gadfly, right? We could try and do the same sort of, actually. Okay, so why not use Gadfly? Well, what if we want to change the colors? You know, you don't like blue, you don't like orange, then what? So for for Vega, what I've done is you define the object one time and then you mutate it. Okay, so we already have a bar plot that I've labeled B. Okay, and now we say, well, you know what? I don't like the default colors. Okay, so I'm going to take my graph B and I'm going to use I built the color brewer scale into this package. And so it takes an argument, in this case, a tuple. So I'm going to make it green of some sort. Okay, and I know I have two groupings. The minimum is 3 for color brewer. Okay. So again, I picked a color scheme that's kind of washed out. But the point still remains that changing the color here is just saying, hey, you know, I want to change the color of this graph. I don't really want to get into, you know, I don't need the finite control where I want to change just one bar. And I don't want to have to remember, you know, where the color goes. Here, what I've done with the Vega package is created a series of functions that just mutate the original object, and they have really obvious names. So color scheme's pretty easy to remember. There's only 2 arguments. One of them is the graph that you want to modify. So this is what I've been trying to do. So what if you want to do this in Gadfly? So we could do this. Hopefully this doesn't bite me. Okay. So at the defaults, I mean, Gadfly can be very, very simple as well. You don't really need a lot of arguments. The way it's set up is there's one common function plot, and then you start passing the shading type that you, or the shape that you want, and the colors, and you know, grids, and all sorts of other things. And so when we plot this eventually, okay. So this is roughly similar to what I did. Okay, it's not the same, but it's kind of the same concept, right? You pass in your data, you don't care about anything else, you kind of get back what you get back. And then the difference between my chart and this chart is, well, now the x-axis here doesn't know that it's it doesn't have the same binning, and the groups are out of order, and the x-axis or the y-axis doesn't know how far it should go up. So then we can start manipulating the parts of the graph that we want to fix. And once we start doing that, then it quickly becomes cognitive overload. So, you know, if I want to make the x-axis discrete, okay, now I have to remember that it's in the scale portion of the package. Okay, that's not too bad. Okay, and I want to make y continuous between some set of values. And then when we're talking about the colors of the bars, that's part of scale. Well, I don't think about it that way. I think about the scale as being, you know, the axes, but that's where we change our colors. And then I don't like grids on my charts, so I want to turn that off. Well, that's part of the theme. Okay, so it ends up being that you have to sit there with the documentation open. Okay, premature end of input, of course. Okay, so so again, it's washed out, but so these charts are now vaguely similar, right? You know, it's not that Vega produces better quality graphics than Gadfly, or Gadfly produces better graphics than Vega. In fact, they both use the same back-end engine. They're both related to D3 in some way. So it's not that you can't do anything, and it's not that I'm introducing any new functionality. It's really just to reduce the cognitive load of not going through all of these steps to make a chart. Okay, so both libraries do the same thing. Yeah, they do. Like I said, there's a high cognitive cost. And so my goals for this package is really, as I said, to create the minimum declarative plotting syntax so that you can always get back something that's roughly aesthetically pleasing as fast as possible. But the second point is that because you're mutating the object each time, you can actually go inside of the Vega type that's defined and change any of the properties you wanted to. So if you really wanted to go through the documentation, and by the documentation I mean the Vega documentation, not the Julia documentation, and you wanted to change one property, you can actually do that. But in general, really what I'm trying to do is just provide the most common types of graphics and to be able to get there as fast as possible while working. Okay, so I just made a few selected examples. The documentation for this is under John's name because he started it. Maybe we'll get a custom domain sometime if anyone starts using this package. But the absolute current state of the package is documented. So if it's possible, you'll be able to see in the documentation. If it's not possible, it's because it's not. So suppose you want to do an area plot with a customized color scheme. So we call area plot, in this case, use the red color scheme. Literally milliseconds to render the graph. Building maps is a little bit more complex, but it can be done. So right now, the only one is the default one that you see in every other package, which is at the FIPS code level, or the county code level. And here you can see I've also used a function called stroke, which only takes one argument, saying, well, by default, I want to draw little arrows, or excuse me, little borders around the chart. If you didn't use stroke, okay, you get something like this. So again, these very, very simple functions that just kind of mutate your object. And there's nothing that keeps you from stacking it. So if I could actually do So you can pretty much guess the colors that are available: greens, purples, reds, yellows. You can stack those functions on top of each other. It works the same way. It's just as fast. So let's see if I have any more examples. I have, as far as I know, you can't do this in Gadfly. It's not that it's not possible. It's just that it's not defined. So a population chart where you want to compare two populations on the same relative axes. So this is just population of people by age in 1930. So it's a trivial example, but it just goes to show that, again, these are all one-line things. Most of the functions take an X argument, a Y argument, and a group argument. And then you can kind of reason about the other pieces. Like, for instance, you do know that there is such a thing as a stacked bar chart, so there's probably a stacked parameter. The pie chart only only takes one set of values, so there's no X parameter. So again, I'm trying to make it really low cognitive overhead of making graphics very quickly. So collaborators wanted. So for a while, this was just abandoned. I just got bored one day at the same time as being interested in interactive web graphics, so I decided to fix it. Vega works on both version 3 and version 4 of Julia, so no matter which one you pick, it will work fine. The code base is relatively simple. All the plumbing's there. So this works inside of Jupyter Notebook, and it works at the REPL. So if you are working at the REPL, it will open your browser automatically and then show it in your browser. So this is actually very useful. So what ends up happening is if I need to make a graphic for sharing, I often do it in the notebook and then copy the code into the REPL, so it'll just put it in a nice blank web page, and then it's very easy to just make a screen print of the graphic that way, and then you can put it in PowerPoint or Keynote or whatever that Linux slideware is that everybody uses, or LaTeX or whatever. there's also an online editor where you can actually see other examples. So here, if you wanted to start participating, I want to eventually build force-directed network graphs. And luckily, Trifacta, which is the group that built the Vega library, has provided examples. So in order to get this into Julia, you basically just need to map some or all of this code on the left, which is just plain JSON, into the Julia types, and eventually a force-directed graph would come out. So anyone who's really interested, again, who wants to contribute somewhere but is kind of intimidated by anything, really willing to work with anyone to kind of see if we can make this make Vega a useful package. And the to-do list is quite extensive. So while you can do a lot of things, there's a lot of things you can't do. So we don't need to go through this, but I mean, there's any number of things I have on the to-do list. So again, if there were people who wanted to contribute, I'll eventually put this to-do list inside the package so that people can see it. But you can modify functions that are already there, create new visualizations, just do things plain better, make them faster, whatever. Write documentation. I'm really open to anything. So if there's people that, like I said, are out there, like Leah's presentation, if you want to do something a little bit further than correcting people's typos, this might be a great place to actually do so. So if there's anyone interested, just kind of throwing that out there. Otherwise, that's it. Thank you. No, are there any questions? I think so.
Is Vega pretty stable at this point?
In what way?
Well, it's a sort of middleware of a sort.
Right.
Programming language in D3, right?
Right. So Vega is a wrapper on D3. So just to give the background I didn't have, since I have a few more minutes. So D3 is really low level, and you have to program in JavaScript, and you have to attach all the properties to your data points and tell the browser where you want to put them and so forth. And then Vega is a wrapper around D3 that's declarative. So you use JSON to tell the Vega JS library how to plot D3. Okay? But as it turns out, writing JSON is not particularly pleasing either. In fact, it may be worse than writing JavaScript itself. It's easier, but the nesting is kind of so-so. And so Vega itself is very stable. They're somewhat in a transition period. So they're on, I guess, version 1.5. And it's kind of silent right now. I talked to the maintainers of the project, and they're actually writing a second version, which is why you don't see a lot of talk of Vega. The second version is going to have a lot more interactivity. So you can do more compound type of graphs. So like if you have ever seen some of those graphs like in the New York Times where you move a slider and like 3 other sliders move because 4 data elements are all a function of that. They're building that type of functionality in. So, but as far as the JavaScript goes, yeah, it's as stable as anything. There's never the JavaScript library is actually part of the Vega library. So in terms of Julia stability, it's going to be as stable as anything because I'm not going to switch the JavaScript library out. So, until they do version 2. Anyone else? All right, well, thank you for listening to my talk, and I don't know.